Hello, hello. Oh, okay, yeah, that works. Does it work? Okay, good. All right. Welcome everyone to this session, which is a joint session between the Benchmarking Working Group and IPPM. It is 2:30 local time in Madrid, and we're about to kick off. And I will hand it over to Giuseppe.
Yeah, hello everybody. I guess all people here are interested to BMWG and IPPM. Otherwise, the room is not your room. Let's start the meeting. So as usual, every IETF meeting, you have to look at these IETF policies to know that. In order to agree and follow IETF process and policies. So there are all the documentation. You can always ask working group chairs or area director in case of need. In addition to Note Well, we also have Note Really Well that highlight that IETF strives to create and maintain an environment in which people of many different backgrounds, culture, identities can interact together with respect. So there is also, so if IETF participant must not engage in harassment, harassment is unwelcome, hostile. So, and if you believe that some of this behavior is happening, so you may raise your concern to the ombudsperson. IETF meeting type. So make sure to sign in the data tracker. There is also a QR code in this session. If you are on site, it is suggested to use the on-site tool. You always need to join the mic queue and to participate in shows of hands. For remote, make sure that your audio and video are off unless you are presenting or sharing. Yeah, this is a joint session, as said. Why we are organizing this joint session? So because we noticed after the suggestion of the area director Matt that there are some similar topics that we want to facilitate the exchange, the discussion, to increase the reviewers. We're also seeking feedback from both working groups, so to familiarize which topics and documents are being discussed, and would like to see much more activities, especially in terms of review. A quick look at the two charter. The benchmarking methodology working group charter is tasked to produce recommendation about the key performance characteristics of networking technologies, network device, systems, and service in terms of benchmarking. The set of benchmarks will be developed with the input, of course, from different users, network operators, testing organizations, and also from those that are affected by the benchmark, so networking and test manufacturers. It's important that the scope of the benchmarking working group is delimited to the characterization of the networking technologies using controlling stimuli in a lab environment. So this is the main difference with respect to IPPM. So, and therefore, benchmarking working group does not attempt to produce benchmarks for operational network. For IPPM, maybe Marcus would.
Yeah, sure. So IPPM then does focus on measurements over the internet. So we can say that it is tasked to develop and maintain standard metrics that can be applied to quality, performance, and reliability of internet data, delivery services, and applications running over transport protocols, typically like TCP, UDP. It develops methodologies, protocols for measurement of these metrics. So the metrics and the measurement methodologies are developed to provide an unbiased quantitative performance measurement. So it's really about being able to measure real networks using standardized metrics and methodologies. It also works on fostering commonality and comparability of metrics and measurements across IETF protocols at different layers. Currently, it's limited to metrics and methodologies that are applicable over transport layer protocols, or IP. And it does not specify encapsulations required for measurements over non-IP layers. So yeah, that's the main difference here between these two groups, that this is really IPPM methods and protocols, and metrics are really designed for operational networks. Yeah.
Okay.
Yeah.
As every working group session, we need the note taker. So any volunteer, we have a collaborative tool. So I know that Thomas already helped, but if someone else would like to add more
So in particular, like Thomas here will take notes, but it would be great to have a backup note taker. Yeah. Okay, Ike, thank you very much. You have the link in the chat there as well. So.
Yeah, thank you. That is the agenda. So we have a very full schedule today because, since we have a joint session, we have to discuss the working group documents of both working groups. IPPM will also have an additional session on Thursday. We also have, in addition to the working group documents, we also have new proposed work. These are mainly for benchmarking working group, while the proposed work for IPPM will be discussed on Thursday. Of course, there is some agenda batch, so if time permits, there are 2 presentations pending. So just a quick updates on benchmarking working group status. So the MLR search draft has been submitted to ESG for publication. MED review has been addressed in the latest version. There are 2 documents preparing for the working group last call, the segment routing benchmarking methodology draft and a network tester. So basically the Young data model for network test configuration. The milestone will be revised accordingly after this meeting. There are 3 drafts on benchmarking for energy efficiency for SaveNet and the multiple IP address benchmarking that are candidate for the adoption, which receive recent discussion on the mailing list. Other proposals are coming. Of course, you can always look at the BMWG document status. And yeah, there was also some discussion for revisiting BMWG RFCs in order to update RFC 2544. This slide has been provided by the author of MLR search draft. So basically, yeah, I can present on behalf of the author. So they address the comment in the latest version from MED. They, of course, thanked MED about these additions that improve the document. Basically, they add 2 new sections about how position the MLR search with respect to other BMWG methodologies. And also they clarified the scope in the MLR search specification section. They also mentioned this email thread about revisiting BMWG RFCs that can maybe bring a new draft in the coming months, considering the analysis that they are doing.
All right, and a quick update on IPPM documents as well. We have the draft IPPM capacity protocol. It's in IESG. It's been receiving a lot of reviews from Performance Metric Directorate, Genart, and Obsteer, and so on. It's been a long process of reviews. I think it's making good progress. There has been substantial reviews. It is a complicated protocol, but progress is being made. So thanks to everyone involved in this, because it's a tough process. We also have the asymmetrical packets drafts that went through working group last call. It was concluded working group consensus was declared on progressing the document. There is an ongoing Shepherd write-up there. There is a document that was adopted is the on-path telemetry Yang document. It has also received an early Yang doctor's review with some very good feedback, I think. And recently we did a working group last call on quality of outcome. It also there received a lot of feedback, and we saw that the authors have produced a new document to address that feedback. So we're now looking forward to more feedback on that updated document before we progress it.
Okay, I think we can start. It's the last slide.
Yeah.
We are already out of time.
Yeah. So we're jumping into the presentations, and the first presentation will be Greg on asymmetrical packets. Let me see.
Why I cannot?
Where do I add the slides?
Yes.
Slides. Oh, yeah. Let me see.
Are you sharing?
I'm trying to find.
Second.
Okay. Is it this one?
They are numbered, yeah.
Okay. See. Yeah, that one. Yeah, perfect. And you want the clicker?
Yeah, if it works.
There you go.
Hello. So as was mentioned that we had a last call, and I appreciate all the comments, the discussion. It was very helpful and productive. So let's review the changes that resulted from those discussions, part of their working group last call. So we invited Will to join us. Will brings experience of implementing not only STAMP and STAMP extensions, but he keeps in with all the proposals that we have, and one of their STAMP extensions that already supported by the Tea Party open source implementation of STAMP and extensions includes the functionality in these asymmetrical packets rate measurement draft. We updated their format to make it denser because we believe, so in the course of discussion, we agreed that basically all this broader ranges are not useful. So thus the format is denser. And introduce the conformance reflected test packet flag. So it's a new STAMP TLV flag that will be more informative and easier to identify the conditions as experienced by the reflector, because there were concerns, and we have very productive discussion on that their session reflector is ultimate source, because it's responsibility to generate the sequence of requested reflected packets. It's the source of determining whether the rate of packets and their data volume might be exceeding their capacity. So for that purpose, the conformance reflected test packet might be set to indicate that the session reflector does not sustain, cannot sustain the requested flow of a reflected packet in response to a single session sender test packet being received. So also we added operational considerations that should be useful or could be useful for operators deploying this functionality of multiple reflected packets, and expanded security, and also based on their experience and of implementing this functionality in Tea Party open source managed by Will. So we added implementation status page that as usual will be for informational purposes, but to be removed when the document gets to the publication. So as I said, so we went for the denser reflected test packet. And that's kind of at expense of length of reflected packet and the number of requested packets. So the conformance packet stamp, as I mentioned. So their session reflector is the ultimate authority on evaluating their possible impact of following on the request from the session sender. So that if their reflector, under conditions that it deems that the requested volume of packets and the rate of packets exceeds the conditions and the reflector capability, so it will send a single reflected packet and will set up the conformance packet stamp till we indicated that the request cannot be sustained. So the next action, so it's based on sophistication and procedures that operator will find. And also basically what, let me go back because that's another for operational considerations. So as usual, the rate measurements can be done both out of service and in service. So in operational considerations, we indicate that for their in-service measurements, it's recommended to start with their slow rate of reflected packets, so to minimize the possible impact, because it might create a bottleneck. Whereas in out-of-service testing, this requirement might not really be that significant, and also, yes, it can be considered, but we would not recommend it because it's out of service. So, and sometimes creating the bottleneck is something that really there might be a goal of this testing, to really identify this possible. So implementation status, as I mentioned, we really appreciate the work that being done by Will. There might be some interesting ideas that we have, including possible interop during their hackathon in Montreal. So stay tuned, and if you know of stamp extension implementations, reach out to Will. Let's go directly to him. But so far, I know that there's some interest in some implementations that are available in the industry already. So really excited about it. Their implementation status has some information, this section about this interoperability with their TWAMP-wide implementations, because one of their ideas that we put in the stamp is that in unauthenticated mode based stamp implementation can interwork with the TWAMP-wide, which is in unauthenticated mode as well. So there are some interesting aspects to that. Again, what I suggested to Will is just start informational draft, which will summarize his experience and findings and ideas and recommendations for really ensuring this backward interoperability between two protocols, which I think that will be really beneficial to the industry and network operators. So with that, we are ready for the next steps and really looking forward for the write-ups. Any questions?
Boris?
Not really question, just comment. I'm really happy to see what we finally have open source stamp implementation. It's so great progress. Really appreciate it.
Yeah, and again, all the kudos to Will.
Anyway, yeah, to you and Will and the whole people.
Yeah, but
thanks.
Yeah, hats on to him.
Yeah, from a chair perspective, also very, very glad to see that. It's always good to see running code. It helps drive the progress of of all the spec work that we're doing. And it sounds very interesting with some activities on the hackathon next time. So
Okay,
Thanks
you.
a lot.
Paolo?
Next up is Paolo. Yep. I have to take back. Yes. Yep. And then click. Now it should work.
Hello, Paolo Volpato, Huawei. As usual, we are presenting this update at every IETF, which is about the benchmarking methodology for the segment routing capable network device. You see, I'm presenting on behalf of the co-authors listed here. So just to give a very quick introduction to the draft. As I said, the scope is to benchmark the segment routing capable devices. So we developed the draft taking as the foundation the several drafts available, the several RFCs available on benchmarking. We also, let's say, extended the scope because we had to touch with different topics, including how to benchmark segment routing, which you know, the RFC was not available before. About the history of the draft, well, it was adopted at the IETF 119. Then we developed a couple of versions, so 01 and 02, that touch the, I would say, the bulk of the remaining description for the functional tests. Version 03 was presented at the last IETF. Probably we can consider the first very stable version of the draft. And for that reason, during the last IETF, we decided to cross-post the draft to the other working groups, which are, let's say, dedicated to segment routing, so Spring and SRv6 ops. I would say the result of the cross-post was good. We get some feedback. We received some comments. We are listing here just, I would say, probably the most notable remarks we got, both from Boris, who is sitting here in the room. We were able to provide, let's say, further revision of the draft, and you see that actually we uploaded version 04 just before this IETF. Very quickly, the first one was, in section 6, which is the description of the test, we didn't mention the possibility of having multiple methods to build a long SID. Actually, we fixed that in section 6.1, which is mainly about the throughput of the throughput test. And then the second comment from Boris was, in case we have an SR policy with just one active candidate path, there could be the possibility of modify the segment list, the seats, check the load balancing capability, and so on. Okay, so we think we have addressed that in section 6.1. We had some discussion, actually, to understand the scope of your comment, Boris, so we believe it could be associated to the benchmarking of the scalability of a network device and also the ECMP capability. If this is the case, we are happy. Otherwise, we're open to further comments. In any case, thanks to all the people that actually provided comments on that. And then just after the cutoff date, we received other comments from Dan, one of the chairs of SRv6 Ops. Actually, I would say those are quite valuable comments. In some cases, I believe the method is just to probably clarify the text of our draft. In other cases, there is something that probably we forgot. Again, very quickly, the first one is about being even more, how can I say, clear in the introduction to state what is really out of scope of the draft. There is something in the introduction saying, okay, we are not considering the SR, in quotes, services. And I would say Dan is correct in saying, okay, please list what you mean by services. So we'll fix that in the next version of the draft. Then there is the second comment about creating a test matrix. because that makes the test result more readable. If you look at section 5, which is the section in the draft, the chapter in the draft that describes the test format, it's a sort of template. Actually, the information is already there, but we fully acknowledge that having a kind of matrix, sure, makes things more readable, more probably even simpler to describe as a test result. Then we have the third comment, which is to add a benchmark that measure the throughput and or latency, specifically when the device under test is, let's say, inserting the SRH into the packet. Well, we believe that this has been described again in section 6.1, which is probably the most comprehensive description we put in the draft. But if it is not, well, we will evaluate whether we need a dedicated test or there is something to add in addition to that. The fourth one is to spell out the separate benchmark for either next C seed or replace seed. That's a good point. So thanks, Dan, for pointing that out, because actually in looking at the test report, we saw that we missed that information. So for sure that will be something that we will add in the next revision of the draft. And the final one, there is again something about the, let's say, the scalability test, so the scalability benchmark of a network device. So to identify the maximum limit of the fib or seed table. Again, we believe that when we speak of scalability, there are several references in the draft. So probably it's already there, but we will take the opportunity to review the text and see if a new text or maybe a wider description can be inserted. Now, just to conclude, so next steps. As said, the version 04 has been published at the beginning of July. It's the stable review of the draft. Please feel free to comment and provide your feedback. Our plan is to publish version 05 for the next IETF so that we can address all the remaining comments. We will add a reference, at least one reference to public test, and we thank Gian for sharing the information just before this IETF. We will probably elaborate on that at the next meeting. There is also a mention from let's say, the I2 study group, IQT study group, SG11 issued a liaison that is also relevant to our work, so we'll probably include that in the next review of the draft. And I would say that's it. We hope that if the draft is stable enough, so we don't receive any, let's say, critical update, we'll ask for the last call, the next IETF. And I would say this is it.
Okay, thank you. Any question, comments?
If not,
Yeah, maybe Dan is not in the room, but maybe a follow-up with him to double check with
yes.
the future change would be good for
Thank
the
you.
new
Yeah,
revision.
for sure, because those are important, the important remaining comments.
Yeah.
Okay, thank you.
Thank you.
Thank you very much. In our agenda, the next topic is quality of outcome, but we do not see Björn here in this session, and we did not receive his slides. So unless we hear from him within 5 seconds, we'll jump to the next agenda topic instead, which is responsiveness, which will be presented by Stuart. And I think you can join Stuart. Would you like us to drive the slides for you, Stuart?
Whichever is easier. If you can give me control, then I can click it from this end.
Yeah, sure. Let's do that. You should have control now.
Excellent. Thank you. I'm giving an update today because we have achieved, I think, an incredible milestone, culmination of an enormous amount of work. Is my voice clear at that end? I'm hearing a bit of an echo. Is my voice clear enough?
It's okay in here, I think, at least from the chairs table. Is it okay down there? Yep. Okay. People are giving thumbs
Okay,
up.
I'll continue. This is the end result of a heroic amount of work, starting with ECN and L4S, TCP Prague, and getting that deployed, getting that implemented in iOS and Linux, and getting that deployed in shipping software, and of course writing the benchmark tool to measure it, and the amazing work that Cable Labs and Comcast have done to get this deployed. And all of that work culminates in this seemingly small milestone, which I was able to run some working latency measurements on my home Comcast internet connection and see the results of all of this coming together. Not only me, anybody else can too. So you can install this with the latest iOS 18.6 beta or the macOS beta, and that will be in mainstream shipping software very soon. And I will present the results I have here. I encourage everybody else to try those experiments. If you have Comcast service, then try it out and see if it's working. And for network engineers who are considering deploying L4S, you now have tools that you can measure and see the results for yourself. We'll cut to the punchline here. We saw a halving of working latency. And that is compared to Comcast's current service, which is already excellent and vastly better than a lot of other operators. So for those who don't know, on your iPhone, you can enable developer mode. And when you turn that on, you see extra settings. And there are settings for L4S. You can leave it on default, but we also have settings to force enable it and force disable it. Makes it easy to see the results with and without L4S. When you've done that, you can run a responsiveness test. And I always also encourage people to try FaceTime. FaceTime has preliminary support for L4S. So try doing a FaceTime call with your friends with L4S enabled and disabled, because benchmarks are important, but benchmarks are only important to the extent they reflect real-world experience. So look at the numbers and also look at the real-world experience. So here are the results. This is my Comcast Business Internet, which is the service I pay for at home and have done for a long time. Very happy with that. And the idle latency is around 25 milliseconds, which is great. And during saturated uplink or downlink, that gets worse. To be very clear, if you run this on other networks or mobile carriers, you'll see it gets much, much worse during activity. So Comcast is already doing a great job here. This slide is results using the Comcast Xfinity residential internet service. And the first one you'll see in the command line, I specified no L4S to disable L4S. And we see similar results. The idle latency is around 25 milliseconds, but if I'm uploading a big file, that doubles to 50 milliseconds. And then these are the triumphant results of L4S. During saturated upload or download, the round trip time stays within statistical significance, basically the same as the idle round trip time. And that's pretty incredible. You can completely saturate your network and the latency behavior is basically unchanged from when the network is idle. And we knew this was always the goal of L4S, but it is very exciting to me to see that borne out in the experimental. So Getting back to the responsiveness draft, this document has come a long way, and we were thinking recently it was time to publish it. In retrospect, I'm glad we didn't, because it's given us the opportunity to address some feedback. One criticism we've had from an early version of the draft, it classified working latency into poor, fair, good, excellent. And that got taken out at some point. We've had people complain that these numbers are arbitrary and they don't mean anything, and we shouldn't be expressing value judgments. So what counts as poor and what counts as good? Because not so long ago, a 1 megabit internet connection would be considered really high throughput, and now that's not. And that led us to think about this. And there is new text in the latest update to the draft to address that, because I don't believe they are arbitrary, and I don't believe they change over time. So there are a couple of new pages in there that talk about why what we consider good responsiveness today is likely to remain a good guideline for the foreseeable future. And that's based on a couple of things. One is physics, speed of light relative to the size of planet Earth, and that's not going to change. So there are some low limits of latency that we know we will never beat those times for a round trip time, not unless we have some big breakthrough in physics, which is unlikely. And the other factor is human factors. To have a conversation, if the round trip delay is too high, then human conversation patterns break down. And we don't expect human psychology to change significantly. So there is new text describing that. We've also been seeing discussion on Reddit of people being confused about this test, and I wanted to point them to the draft and tell them you can read this to understand it. And I realized that there are certain things the draft didn't explain very well, so this is an opportunity to add those explanations. One in particular that I thought was very interesting, we saw people complaining that when the test does upload and download simultaneously, for some people, the results are terrible compared to doing individual uploads and downloads separately. And there was a big push to say we shouldn't be testing concurrently. And I disagree with that quite strongly, because the whole spirit of IP networking, packet networking in general, is that the network can do more than one thing at a time. This is not like a phone line where you can only make one phone call at a time. The whole point of a shared datagram network is you can do multiple things. You can have multiple devices doing things at the same time and multiple applications on the same device doing things at the same time. And if we find cases where there is a network technology that can get decent upload throughput and decent download throughput, but if you try to do both at the same time, it fails catastrophically, I think that's something we really want to know. And there was a tendency in some of the discussions, people said we shouldn't measure that because the results are so bad. We should do the test sequentially. We should make that the default. And initially I was going along with that. And I thought, hang on a second. We shouldn't avoid measuring the things that don't work well and only focus on measuring the things that are great in order to get impressive numbers. The point of a benchmark tool like this is to expose problems that need to be fixed. So that is an area I think we need to explore. So my proposal for now is to keep this as a working document, keep taking this feedback, keep making refinements. And I'm kind of glad we did not publish as an RFC prematurely, because then we wouldn't have the opportunity to make these improvements. Well, thank you. If we don't have any questions, we can move on.
Thanks a lot, Stuart, for that presentation and that update. It's also good to see experimental results, and it's good to see L4S working as intended. It's very encouraging, I think. I think it's just talking here is maybe without the chair hat on. I'm thinking you were mentioning some pushback on using too much kind of value words and such on the results, and I I to some degree agree with that, and perhaps it would be very interesting to see how how this methodology works together with something like the quality of outcome framework, where you actually let perhaps the applications themselves determine what is constituting good, fair, or bad, or worthless results, right? Rather than perhaps specifying it in this protocol or methodology document. So I don't know if you have any thoughts around that.
Yep. That's a good suggestion, and I should work with Bjorn on that. I believe very strongly that benchmarks are only useful to the extent that they correlate with user experience. And we have to establish that the benchmark scores relate to user experience. And if they do, then the benchmark becomes a good tool for evaluating whether software changes you make are improving things or making things worse. But tying those benchmark numbers to something meaningful is key. So that's a good suggestion. Thank you.
Thanks a lot. And then we'll move forward in the agenda, unless we have any more comments here.
Rakesh.
Oh, I have to. Oh, yeah, something back. And you should have control now.
Good afternoon, everyone. My name is Rakesh Gandhi from Cisco Systems. I'm giving an update on the reflecting stamp IP headers on behalf of my co-authors, and also like to welcome William as a co-author. So agenda is basically look at the requirements, what updates we have made, and the next steps. So requirements using stamp for hop by hop and edge to edge measurements, two-way as well as one-way measurements. And our goal is to use the existing implementations on the midpoint nodes, so they are not aware of the stamp protocol on midpoints. The scope is a stamp and stamp extensions, and in this document is the IP data plane. So the update we did is that we split the draft into two drafts, one for IPv4 and IPv6 data plane, that is this draft, and there is another companion draft we split into for the MPLS data plane. So just to recap the procedure that we have for stamp extensions, we have defined TLV that is sent by the sender to get the receive IP headers back, as well as the extension headers. So reflector basically copies the receive headers into the stamp TLV and sends them back to the sender. And the purpose is hop by hop as well as edge-to-edge measurements. And there are many use cases. And there is a control over one-way and two-way measurement using the stamp asymmetric sub-TLV. So next steps, thank you, Will, for your great work on Tea-Party open source implementation for this draft. Welcome your review comments and suggestions, and we believe the draft is ready for working with last call. So any comments, questions? Thank you.
Right, so if no questions, thanks a lot. And yeah, again, I'm really happy to see that we're getting open source implementations. I think that is really, really excellent. We will put this to our backlog of requests, and we will revisit it after after this meeting.
Thanks. Yeah. I think next one is.
There is another presentation.
Yeah. You have to take back control. A lot of clicks involved there. Let's see. So, here's slides. There we go. And I will give you back control again.
So this is a companion document I'm presenting on behalf of my co-authors for the reflecting stamp MPLS headers for the same requirements. So we'll give an update as well as next steps. So again, hop by hop and H2S measurements for one-way and two-way measurements. In this case, is the implementation for M&A. M&A is the work, MPLS Network Action Substack work that's happening in the MPLS working group. And this work is leveraging that work. There is M&A for in-stack as well as post-stack solutions defined, and that's the scope of this work. So update is the draft was split into two drafts, and this is the MPLS counterpart. Idea is very similar to the IP data plane. In this case, it's M&A substacks that's carried in the MPLS header, in-stack as well as post-stack headers, and the reflector will copy back those substacks into the stamp TLVs to the sender. Next steps, this was previously part of the working group document. So we welcome your review comments and suggestions, and we do believe it's ready for working group adoption. Thank you.
Any questions or comments on this one? All right, then thanks a lot, Rakesh. We will also take the adoption call into consideration and revisit it after the meeting. Yeah. Thank you.
Yeah, the next one is GOG, Tran. It should be remote.
Hello. Can you hear me?
Yeah, very good.
Okay, thank you.
Would you like control of the slides or?
Yes, please.
So you should have control now.
Yeah, excellent. So hello everyone. So this is an update of the working group draft about considerations for benchmarking network performance in container infrastructures. I'm Gopchan and I'm presenting on behalf of our authors. So again, this is a quick scope reintroduction. So this working group document aims to extend the previous IFC about NFV benchmarking, where the previous IFC have not considered about the container in NFV infrastructure yet. So in container environment, we have extra consideration like container networking models and container resource configuration. These extra things that is unique to the container environment. So in our latest update of the draft, we received feedback from Libin in the mailing list. So there are two things that we have review about that and inside the document. So the first one is comment about the configuration of a certain technique that should be considered. And actually, we have put in some CNI configuration already inside the draft. So first of all, like the post page, we have an we already have a section for that. AF HTTP also have a section for that. And the thing I left is just a small thing like NUMA core location to restrict and unique card, which are part of the configuration for user space association CNI. And we also add online to help the reader to be clear about the scope of the document, whether some of the configuration about the VNF and vSwitch are not mentioned inside the document because they had already been mentioned and discussed in previous IFC about the vSwitch and the NV. About the second update is about the service function chaining, and it's actually a very helpful one. So we add the two new configuration here, two new consideration here about the first one is the CNF composition, where we have in some case a CNF can be part of multiple service chain, and it can be part of a sequential or a parallel service chain. And another thing is that the resource scheduling policy inside service function chaining might be varied. Because when you have multiple CNF, and sometimes the CNF activation time and the CPU allocation time will be different for different CNF. And this kind of result had already been published in a paper, a related paper here. So this is a quick review about the history of the working group document. After adoption, we have go through several versions of update based on the command from the mailing list. So is there any new review or any new suggestion? We will happy to enhance the draft once again. And if not, I believe that the draft is good for the last go. Thank you.
Yeah, thank you for your presentation. There are comments in the room or remote? Okay. Regarding the document, I think is in a good state. So for the last call, there is a queue, and together with Sarah, we will discuss how to prioritize, and probably after this IETF meeting, you will get back from us. I just want to point out a new draft that has been presented before the submission deadline that, if time permits, will be also introduced today, that define the benchmarking methodology for Kubernetes container network interfaces in edge cloud environment. So I'm wondering if there are some similarities that you can investigate or with the co-authors of this new draft, but it's just to let you know about this new draft that will be presented today if time permits. But if it will not presented, you can have a look just to understand if can influence in some way your work, but just to let you know. Okay, if you don't have any other remarks, maybe we can move ahead.
Yeah, we move forward, and then it's going to be Giuseppe presenting.
Yeah, okay.
We'll be presenting 3 drafts, I believe.
Okay, yeah, this is a quick update about the alternate marking deployment framework. There is no update since the last IETF. I just want to summarize the status, because since this draft aims to provide guidance for the alt-mark deployment, it maybe define different aspects for the manageability related to the implementation to a controller domain, the rule of the different nodes, the type of measurements that can be done, and it covers both configuration and data export aspects, and also the different encapsulations for the alternate marking implementation. In this slide, I just want to point out the relevant drafts that are all adopted or in different phase waiting for the working group last call. For the configuration, you can see the Young model, the PSAP, BGP extension, and also for the data export, we have defined the IPFix and Young push extension. So this is just to show the current status and to point out the relevant documents. This is all. So, of course, the document should be ready for the working group last call, but of course, comments are always welcome.
Do we have any comments here at this point? If not, we will, as we say, we will take this to consideration into our backlog, and we will work on the priority order. And we will move forward to the next, let's see, I have to take back.
have put everything in one document. But I want you to click.
Yeah.
Okay. Yeah, this is one of the draft mentioned before about the Young data model for the alternate marking method. This draft has been updated according to some feedback also related to the Young push document. It defined the Young model for the alternate marking. Important thing that it followed the same structure of IOM Young model to simplify an implementation. You can see all the related relevant parameters. I just want to highlight that as for the RFC 9617, this is only a configuration model. Yeah, the change from the 00 to 01 versions aims to address comments received from Alex and from Martin. The comment from Martin was related to the Young push document, but also helped me to fix some issue in this document as well. So basically, we replace the measurement period. We replace period with measurement period name in order to avoid any confusion with Young push parameters. This applies also to this document. And we also replace the name of another parameter to align also the term name used for IPFix and Young push in order to have a common methodology. Also, we added an example in the appendix that Martin suggests that is always good to have example of usage of the Young model. In this case, we believe that the draft is quite stable, so it is in preparing for the working group last call, but yeah, we are still waiting for more comments and feedback from the list.
Thanks a lot. And you're always free to provide comments here. And if you don't do it here, please engage with the documents on the mailing list as well. You don't have to wait until they're in working group last call. It's always good to get discussions prior to any such calls as well. So if no comments, thanks a lot for this one. And we'll move to your last one. So I'll start clicking again here. Yeah.
Yeah, this is about the on-path telemetry Young data model related to the use of Young push for telemetry. This Young model is a little bit more complex because it is used for monitoring the on-path telemetry information both for alternate marking and for in-band OM. Of course, the application scenario is the RFC 8641 subscription model. You can see that all the parameters here are basically read-only. So both for alternate marking and for in-situ OM. A lot of modifications from after the adoptions because we received several inputs from Alex during the working group adoption. Basically, we clarified the need to export IOM and alternate marking relevant data to calculate the performance metrics. As for the previous draft, we fixed some naming like the measurement period to replace period. And we also modify the IOM parameter as the list of the last IOM messages in the period in order to align the measurement period common for alternate marking and for IOM. Also, we received the Young Doctors serially review from Martin. So we fixed the data model, adding the config files for overall container, since all the parameters are read-only. We revised the names of the nodes which don't match the module. We reviewed the security considerations. We also expanded the description statements in some cases, and also in this case, we added the example in the appendix. There is still an open issue. So this draft is not ready for working group plus call, of course. So current version of the draft is that it complements RFC 9617 and the Young data model for alternate marking, which are, as I said, models only for configuration. But another possibility that has been raised during the adoption call and during the discussion on the list was to split the current Young module to augment the two configuration model separately. So to have a part to augment the RFC 9617 and another part for alternate marking to augment the alternate marking Young model presented in the previous presentation. So for this, we are open. So we don't have a particular opinion. So, but we are open to follow the suggestions. So here, so comments are welcome on this open issue. So for now, we have only one single Young model for telemetry, but if the consensus is different, we are open to change and split the Young model. Comments on this?
All right. If no comments, then thanks a lot, Giuseppe.
Okay.
Good to see progress on all of these documents. And next up is network tester configuration.
Vladimir.
Here you go. I'm going to give you control. Have it now.
Yeah.
I think we can take it more.
Okay. Can you hear me? Obviously. So this is the Young data model for network tester management. If you're not familiar, this is something very simple and probably something everyone is familiar with, a network tester that generates stateless traffic and a remote side that analyzes that traffic, figures out how many packets are received, which packets, if there are any packets that were dropped, if there is sequence errors, if there is measures latency, controls the capture. So you can think about if you have this model implemented on an interface, you have a network tester. It is not doing stateful complex operations. We are concentrating on a very simple stateless packet switched traffic description and analysis of the received traffic. So this is what we have. We have the draft that has been progressing for quite a while. We have some implementations used as a reference. We have a open source RFC 2544 implementation in Python that uses the IPA using Young netconf transactions. So in order to implement the device, you have to use a client side and you have to have a device side. The device side is implemented with software using one of the two chains, open two chains, part of Debian. Gateware is written in Verilog because the configuration is translated to registers, and these registers you have to click out the clock out the data, and on the other side receive it and analyze it. So you have a full networking device doing everything from and we have implemented an open source hardware devices. So These are the links. If you have interested in this kind of work, you can look them in detail. And we have, in the latest months, we have done some work on a pre-silicon gate level simulation using the model to configure the simulation so we can run actually RFC2544 test in a simulated gate level environment, which is unusual. What helps us is this model. It makes it easy to just use the user space code doing the script and control the gate level simulation with the script. So this is a summary about how this work has been going. In 2019, we did the initial private submission, reviews on the mailing list forward, some important people who backed the draft. Al Morton, as a specialist in methodology, I would like to mention. The young model level, language specialist, Jürgen, did a very good review. And we got in-session support from Rob Wilton. So that's what triggered the adoption of the draft. As a reference implementation, running code, that's the RFC 2544 benchmark that we have been working on the hackathons for the last years. Open source hardware, gate and gateway device implementation. And in 2022, the draft was adopted as a working draft. We continued work on improvement of the draft and implementation, and the models have been stable. In 2024, we did the last changes in the models, and the last release only has editorial changes and example changes. So the state of the draft, stable. Only change from 5 to 6 release was, revision was E0 as interface name changed to ETH0 because more easily associated with the Ethernet adapter name. No issues pending on the list, not that I know of. Ready for work group last call. State of the implementation, first open source RFC 2544 implementation, both static and dynamic test frame support. The model provides for dynamic test frame support, which is used for the RFC 2544 test. And it is not specifying the particular test frame. So we are using test frame of one of the main producers of test equipment, which currently have been reduced to 2. Like if you, there are some minor producers also for on the field testing, but if you take out Keysight, which is both Spirent and Ixia, this is the one, and Teledyne, it's only this open source network tester that does something similar based on a model transactional configuration of traffic generation. So yeah, and the last time is I talked about the pre-silicon simulation. So this is my presentation. Anyone who is interested in this kind of work should look into the drafts and take contact. It's a very easy to understand draft because it's doing something so very basic that everyone has relation to. And yeah, it's a bit different than what other network test configuration mechanisms employ. It uses modification of the configuration instead of RPCs, which is significant quantum leap in terms of advantages and automation you can gain from Young. So that's why it's interesting. I think it can run very efficiently. And I think this is how people are going to do stateless network testing using similar models in future. Keysight has been watching closely, but they have restrained from contributing to this work. I see that they have added a Young model, which is state only. So you can read the counters, but you don't really configure anything with Young model there. They have they have opened their API. They call it open tester. Yeah, I have looked into it, and it's a good one. If you want to support many features and higher levels, that's what people are using. But it's not a young model based, and this has significant advantages compared to that other model when it comes to scalability and things that that require better modeling. So I think it's a very good draft. I have been working on this for 9 years, including every other block that is part of the ecosystem. And we have consulted people that have the necessary knowledge in all the areas. So thank you.
Yeah, thank you to you. You have one question or comment?
Hello, I'm Wei Yunze from Tsinghua University, and I'm very interested in your draft. I have a question about the scope of test types that this draft or the young model supports. Does it focus on the performance test, or can also support some other types such as protocol conformance or interoperability or some other functional tests? Yes.
Well, these kinds of tests is what you would use on the highest speed interface levels. You would be generating stateless traffic. This is not thing that you don't specify a TCP IP connection, but you can specify IP packets as RFC 2544 does. So this is, if you want to do something fancy, like sending packets back when it's much easier to use SCAPI or something like that. So it's not doing what SCAPI is doing. It's doing something what like RFC 2544 test requires, very deterministic pattern specification of the traffic in one direction. And on the receiving end, you can receive and get some information about how many packets you have received, if there have been any sequence error, if the dynamic frame type that you're using has PRBS, for example, if there are data errors and things like that, but it's limited. And you cannot do protocol validation for complex protocols. For that, you use, of course, Python and SCAPI or something else. So did I answer your question?
Okay, thank you very much.
Yeah, if there are no other comments, yeah, I just want to thank you again for also providing hackathon information and all the history of the draft. If you look at the benchmarking working group milestones, you are the next about the working group last call. So with Sarah, we plan to start the working group last call after this IETF meeting. So yeah, we have a working group adoption and a working group last call to launch after the meeting soon. And yeah, you will get back from us soon. Yeah. Thank you.
Yep. Next up is Carlos for OEM characterization.
Hi.
Hi.
Would you like control of the slides?
Yeah. Yes, please.
You should have it now.
Okay, thank you. So my name is Tal Mizrahi, presenting on behalf of my co-authors, Carlos and Adrian. And this draft is from the Ops Area Working Group, and it's being presented here for the sake of sharing and receiving feedback. Okay, so the goal of this draft is to present guidelines for characterizing or classifying OEM mechanisms, protocols, and specifically one of the goals was to try to create an alternative for the terms in-band and out-of-band, which were used in RFCs in the past, but not necessarily in a consistent way. And one of the things which is not a goal in this draft is to go back and change existing RFCs. We don't want to go back and change the terminology of existing OEM mechanisms which already use specific language. We're basically defining language or a set of guidelines for terms which will be used in documents from now and looking forward. So this is generally the status of the document. It was in working group last call back in October. And then in the last IETF meeting in IETF 122, there were still outstanding comments from 3 main reviewers, from Tim, Benoit, and Greg. And what has happened since the last IETF meeting is, first of all, I joined as a co-author, and we did a major revision of the draft, including a lot of different iterations with the different reviewers. Let's look at some of these changes in a bit more detail. So these are the main changes from version 04 to version 09, so from the previous IETF meeting until now. And one of the main things we tried to do was to focus the scope of the draft specifically on OEM classification. And that means that some of the content which is existed in previous versions of the document was removed in order to focus the scope of the draft. A lot of different clarifications. We added a lot of examples. One of the aspects was since the classification happens in a few different criteria, we tried to analyze how these different criteria work together. Another aspect is that we try to emphasize that we're not changing existing terminology for active, passive, and hybrid, which is defined today in RFC 7799. So that's not being changed, that's being used consistently in the current draft. And also we added some clarification about the importance of equal forwarding treatment of OEM. So these are the main changes. Let's look a little bit, we said OEM classification, so let's look a little bit about what we mean by that. And there are 3 main criteria for classifying OEM according to this document. The first criterion on the left here, very similar to the terminology of RFC 7799, active, passive, and hybrid, exactly the same as RFC 7799. And there's a new term here, which is highlighted in bold, which is in-packet OEM. And it's basically a subset of hybrid OEM, and specifically the case where OEM is integrated into some or all of the data packets. So one criterion is active, passive, or hybrid. The second criterion, which is what we see in the middle, is whether OEM follows the same path or uses a different path than the data that it intends to monitor. And finally, the third criterion, which is what we see on the right, is whether OEM receives an equal treatment from the network, equal as the data it's intended to monitor, or whether it receives a different treatment. So these are 3 different criteria, and let's see what happens. Just an example, let's talk about IP ping that uses ICMP messages. In this case, according to the left criterion, it's active, and then it doesn't necessarily follow the same path as the data that it intends to measure, so it's not path congruent. And it's not necessarily, it doesn't necessarily receive the same treatment as the data. So again, it's not forwarding, it's not equal forwarding treatment in terms of the rightmost criteria. That's one example. The second example is IOAM, and specifically in this example, let's say that we're talking about an IOAM trace option, which is integrated into data packets. In that case, it's going to be in packets in terms of the leftmost criterion. And again, in packet is a subset of hybrid. Okay, in packet means that the OEM is integrated into the data packets. According to the middle criterion, it's path congruent, which means it follows the same path as the data traffic, and it receives the same forwarding treatment as the data traffic. These are the 2 examples in this context.
So just quickly, we have Greg in the queue. Do you have questions on this slide, or do you want to take it at the end?
I just want to summarize, and then I'll open the
Okay, yeah, let's do it.
discussion. So basically, again, we did a few iterations with each of the reviewers, and at this point, we believe that it has converged, and at least from our perspective, we believe that the document is ready, but obviously we're open to any more comments and feedback.
Okay, Greg Mirsky, Ericsson. Thank you for the presentation and bringing it to IPPM working group, which published 7799. If we can go back to slide, because I have a couple questions on the slide itself and what was commented on it. So the first, so in IAM 9127 base specification, IAM in situ OEM is characterized as a hybrid type 1 based on 7799. So in this document, in situ OEM is given as an example of in packet. So are you intended to change information in 9127? So basically saying that in situ OEM is not a hybrid type 1, but in packet OEM?
No, so I just want to emphasize, in-packet OEM is in fact a subset of hybrid OEM. So every protocol or mechanism which is in-packet OEM is also hybrid OEM, and we're not suggesting to change the term hybrid OEM. It remains exactly the same as it was defined in RFC 7799. And if IOM is in-packet, it means that it's also hybrid, because hybrid is the more general term.
Well, that is confusing, because now we have a proposal of using in situ OEM for stamp packets, which is active packets. So if you're saying that in situ OEM is in packet because it's not hybrid, it's really, so, okay, let me ask the question. If in situ OEM enhances stamp packet, would it still be in packet OEM?
Yeah, so first of all, this question would be interesting even before this draft was presented. I think that if we're taking IOEM and we're applying it to control plane messages like stamp,
no, it's not control.
In my opinion, that's active OEM. And also, by the way, there's an active flag which was defined for IOEM. And that's one of the purposes is to kind of use that flag to indicate which traffic is active. But I think generally speaking, if we're using stamp and we're applying IOM on top of it, to me, that's active. In my opinion, that's active.
No, it's not, because based on characterization of 7799, it still will be hybrid, because it's a combination of active and passive, because basically that's what use of in situ OEM brings, because it enhances the other packet regardless of whether it's specially constructed or it's data packet. So still, the combination of stamp and in situ OEM remains hybrid type 1. So
when we take stamp by itself, stamp without IOM, stamp test packets,
yes,
these are active, right? They're active.
Right, but the definition of hybrid in 7799, that it's combination of active and passive. So in situ OEM being hybrid, if we mix active and hybrid, it remains hybrid because it's a mix. So that's where, if saying that we are creating some in-packet classification, which is different from hybrid, that's really confusing. I don't really understand what's the purpose of this in-packet class of OEM.
Yeah, I think the question you asked about using IOM in STAMP, that would be an interesting question regardless of the current draft. I mean, we could have this discussion before this draft, trying to understand whether STAMP with IOM would be active or hybrid. And again, I think it's active in my opinion, and you think it's hybrid, and that's a legitimate discussion even before we start thinking about whether it's in packet or not. If it's hybrid, then I would argue that specifically it's in packet because it's integrated into the packets.
Yeah, but in that case, the in packet is just a different word for hybrid type 1. Okay, so then the thing is that for some reason, this document proposes to have a new term for already being defined in 7799. So basically, what's the value?
So there's a distinction when we talk about hybrid. There's a distinction between what we're defining here as in packet and a slightly different case. And the best example for the other case is inferred loss measurement in MPLS. Okay, when we take inferred loss measurement in MPLS, what we have is different routers or LSRs, which basically keep counters passively. They do passive monitoring of data traffic. But then we have these loss measurement messages, which are exchanged between the LSRs, and they are used just for the sake of exchanging the counter values. And this is exactly the case of hybrid OEM, which is not in-packet OEM, because these loss measurement messages are not integrated into the data packets themselves. They are used in order to exchange the counters, which count the data traffic.
Okay, so as
that's just one example.
Okay, as I understand, this method is called direct loss measurement. And we don't need to use any test messages to collect counters. That's being done through SNMP queries. That can be done with the Yang models. So basically, it's a management plane. It's not a test plane. So hybrid OEM here has, yeah, it can be used. For example, in STAMP, we do have extension to do direct loss measurement, but that's not the only way to do it.
So again, direct loss measurement and inferred loss measurement are two different mechanisms. Direct loss measurement in MPLS is the case where you use the OEM packets in order to perform the delay measurement, the loss measurement itself. And inferred loss measurement is the case where data traffic is being measured and the OEM packets are only used for exchanging the counters. These are two different mechanisms, both defined for MPLS, and they are different in the sense that one of them is active and the other is hybrid.
No, I believe that there is some misunderstanding with terminology, because if we look at Ethernet OEM, so in Ethernet OEM, it's very clear. Direct loss measurement is collection of counters. And synthetic loss measurement, it's where it's using Ethernet OEM packets for synthetic loss measurement. So basically, synthetic loss measurement, when we inject packets equipped with the sequence number and count them, and direct loss measurement, if we have a definition of in-profile Ethernet frames, and we count them and then compare counters. So, but another question is, so when you used example of non-path congruent and different forwarding treatment, if I understood correctly, so you said that ping is always non-path congruent and different forwarding treatment.
I didn't use the word always. I said that it's not necessarily path congruent. It could, in some cases, be path congruent. For example, LSP ping is intended to be path congruent. So that's one example. In some cases, ping ICMP echo messages could be forwarded through specific networks in which they would allow a path congruent measurement. But generally speaking, ICMP, when sent through the internet, is not necessarily path congruent. ICMP could be forwarded through a different path, and it's not guaranteed that it has the same path as the data itself.
But would that be true for any active OEM?
Yeah.
Not necessarily.
So I think we have two more people in the queue, and we are reaching the limit of time here. So let's please move forward.
Yeah. As a participant, I have a similar point than Greg related to the in-packet definition, because I see some overlap with the hybrid definition currently in RFC 7799. So maybe this point should be clarified. I can suggest, I don't know, to make in the next version, I don't know, a table where you can list all the methodologies in IPPM and try to classify according to these new terminologies. And also because, in packet now it looks like there is some overlap with hybrid. So this point need to be better explained and clarified, I think.
Yeah, so in packet, again, it's not a coincidence that it has an overlap with hybrid, because it's a subset of hybrid. It's intended to be a subset of hybrid. That's how it's defined. And the way the draft is phrased today, it states very clearly that it's a subset of hybrid. It also provides a couple of examples of in-packet OEM, which is the distinction between hybrid, which is in packet, compared to hybrid, which is not in packet. So we kind of have that very specific distinction in order to understand what's the difference between using these two terms. But still, if there are any comments about the clarity of this text, I'm happy to hear those comments and to review this text again to make sure it's clear.
Now, I see your point. It's just because now for example, in IOM RFC, in alternate marking RFC, these methods are always classified as hybrid type 1. So since we are changing the terminology, I'm not against, of course, but we just need to maybe in the draft have a table to highlight this kind of change in terms, and it's okay.
Yeah, Thomas here as individual. Just one comment. So in RFC 7799 in section 3A, where hybrid is being defined, there active and passive in hybrid is a subset. So we can have hybrid type passive and hybrid type active. And I think in the document, I think this should be more clearly be described that active and passive is also a subset of hybrid. And then maybe more clearly refine that in hybrid, you distinguish between where basically packets are being modified versus not modified. I think if you could detail that a bit more and also make sure that it actually not changes RFC 7799, that would be helpful.
Okay, yeah, thanks.
Yep, thanks a lot. Thank you for bringing this discussion here. I think it's very good that we have it, and we'll have to move on.
Thank you.
We are moving now to the proposed work for BMWG, while let's say the IPPM documents are finished, and the proposed work for IPPM will be discussed on Thursday, together with BR presentation that could not attend today. No, we have.
Am I wrong here?
No, we have Libin first. This one updates.
Oh, sorry, I missed one.
Yeah, sorry.
Do you want the clicker? Access.
Yeah, you have 5 minutes.
Okay. Hello, everyone. I'm Libin Liu from Zhongguancun Lab. I will introduce the updates about the draft benchmarking methodology for source address validation. This document aims to defining the methodologies for benchmarking the performance of some mechanisms, and it takes the approach of considering a cell device to be a black box and defines the methodologies in a manner that is agnostic to the mechanisms and measures the performance of existing and new cell implementations. In total, we have updated 6 versions. There are 2 objectives for this document. The first one is assessing which cell mechanisms perform best over a set of well-defined scenarios, and another one is measuring the contribution of subsystems to the overall cell system's performance. It helps evaluate individual cell devices and determines the appropriate cell deployment for real-world scenarios. This is a main update summary of version 05 compared to version 03. We have updates on cell performance indicators and benchmarking tests for the intradomain and the interdomain cell. Also, we have some refinements to the document wordings. We received 3 comments from the mailing list. The first one is that we are suggested that we should use false positive and false negative rates to replace the proportions of improper blocks and improper permits, since they are more well-known metrics. We agreed on this and we did the revisions. We also have more reasons because blocks and permits are bound with the fixed discipline actions, such as discard, permit, but more actions can be applied, such as rate limit and traffic redirect, as defined in the general source address validation capabilities draft. Second, we are suggested that a CPU and memory utilizations can be added as a cell performance indicator, since the resource utilizations is important for the router. We agreed on this. We also thought that the router commutation resources are rare and costful. High resource utilizations can reduce their effect on other processes. We have summarized the correspondence relations between the cell performance indicators and the cell performance benchmarking. Here, the false positive and the false negative rates are the cell performance indicators to evaluate the cell accuracy. And the protocol convergence time and message processing throughput are the ones to evaluate the control plane performance. And data plane cell table refreshing rate and data plane forwarding rate are the indicators to evaluate a data plane performance. And the CPU and memory utilization are used to evaluate both the control plane and data plane resource utilization. We also received the feedback from the mailing list. China Mobile had tested the cell device in their intra-domain networks, and the new H3C acknowledged that the benchmarking methodology is useful for their some implementation that they are in their devices. We also have a hackathon project called Cell Bench, which implemented the benchmarking methodology proposed in this document. For next step, we would like to seek feedback and comments in these aspects. Are the cell performance indicators proposed in this document sufficient? And do the intradomain and the interdomain cell tests cover the key real-world scenarios? Also, we appreciate if you have more comments about this document, and welcome to send them to the mailing list. Also, collaborations are welcome. Thank you.
Comments? No. Thank you. I just want to say that I think you are progressing well with the hackathon, also with some feedback from SaveNet people on the list. So I think it is one of the candidates for future adoption, do you think, for BMWG?
Okay, thank you. Thank you. Yeah, we also presented it in some network group.
That's
take
good.
the feedback.
That's good. Yeah. Okay.
Thank you.
Gabor should be remote.
Hello, can you hear me?
Yes.
Okay. Can you also see me?
Yes.
Okay.
And we have given you slide control as well.
Thank you. Where are the slide controls? I can't find it. How can I control the slides? Sorry, I don't know how to control the slides. Can you give me? Yeah, I can see. Okay.
There should be some
I can see it.
arrows.
Yeah, there's a dashboard. Okay, I can see it. Okay, thank you. So thank you very much. So I'm Gabor Lenche from Hungary, and our draft is very simple. We would like to recommend the usage of multiple IP addresses during RFC 2544 and similar benchmarking tests. So this is the outline of my talk. I just would like to mention a few things about the progress of the draft, and then summarize the main point, and then we'd like to request for working group adoption. So here's the next slide. So I presented this draft lately in Dublin. It was version 03. Then I presented some new measurement results and recommended the usage of the test setup, where we use a gateway. I will say what it means. And then we addressed the comments of Boris Hasanov. It was not presented, and the current version addresses the comments of Giuseppe and Libin, and also Olet Rohan joined us as a co-author. So, just a few things to mention. You usually know RFC 2544, that it used a fixed test frame format. It meant that you could send the very same test frame for all the time. However, the development of the industry favorized the usage of multiple processing elements instead of higher CPU clock frequencies. And nowadays, our routers, and even if they are software routers made of commodity hardware, they have multiple units that processes the traffic. So we must share the traffic load among multiple processing elements. One attempt was RFC 4814 that introduced pseudorandom port numbers, but it kept single source and destination IP addresses. If you use a software routing and you use receive side scaling, it supports the distribution of the interrupts and processing load among the CPU cores, and it has two implementations. The first type only includes the IP addresses, and the second type also includes the port numbers in the hash function. And that's the problem, that if we use pseudorandom port numbers and the second type of RSS implementation, everything works fine. However, if we use pseudorandom port numbers with the first type of RSS implementation that doesn't consider the IP, but that considers only the IP addresses and not the port numbers in the hash function, it gives poor results. It cannot distribute the load among the CPU cores. Of course, we should use different solution, because in the real life such kind of router can work perfectly well, and our laboratory test will not reflect the case, but the performance of this kind of router in the real life. So this is why we recommend the usage of pseudorandom IP addresses, and in the previous versions we examined what ranges can be used and what ranges should be used regarding the IP addresses, version 4 and version 6. And the most important recommendation last time when I presented was that we should use a gateway to prevent the problem that we overload the RIP or NDP tables with many mappings. So this is the right way to use a gateway. So our proposal is to use multiple IP addresses, as many as we can, and using a gateway. So we believe that the methodology works well, and we would like to ask for working group adoption of this very simple and straightforward draft. Thank you.
Thank you, Gabor. Any comments from the room or remote? Yeah, from my side, I just want to thank you for addressing my comments. And regarding your working group adoption request, of course, we will discuss. I will discuss with Sarah, and yeah.
Thank you. Thank you.
We'll let you know. Yeah. Maybe we can move to. Thank you, Gabor. Yeah, Carlos is not connected, so yeah, Jen Chen.
Okay, hello. My name is Genchen from Huawei. On behalf of the authors, so this is the update of the characterization and the benchmarking methodologies for power in networking devices. So here's some recap. The benchmarking methodology provides the tools which help vendors to test the energy efficiency of their devices. It was first introduced in IAB E-Impact workshop and site meetings in February 2024. And the first time it was presented in IETF 119. So basically, this draft focuses on two objectives. The first one is assessing which system performs best over a set of well-defined statistics. And secondly, it's about measuring the contribution of subsystems to overall system energy efficiency performance. So in other words, it's a micro benchmark. And several comments and suggestions received and addressed accordingly. So the updates from the last version for this time is to address comments from Gabor. And it's about the test report should not only describe the packet sizes and inter-arrival distributions, but rather should be very explicit about what traffic is being sent, such that it's easier to be replayed. And secondly, the device's temperature change must be known. It's useful to know whether devices treat heat management plays a role in the observed differences in energy efficiency. And for the next step, the latest version, we think that it's a good basis and now ready for adoption. Once adopted, the authors agree on an alignment with Green WG as well. So your additional comments and input are welcome. Yeah, that's all.
Thank you. Luis, you are welcome.
Thank you. This is Luis from Telefonica. One comment here, you mentioned at the beginning that the purpose is as well to benchmark the subsystem components or modules. So is there a definition of what could subsystems would be? Because probably different implementations could have different considerations in terms of subsystem. So I guess that testing a node is somehow a kind of black box, let's say, something unique that we can compare between different implementations, but at subsystem level, I'm not sure if we can compare. What kind of subsystem are you considering here?
So do you mean that for subsystems, how to compare them?
Yes, I mean probably in one implementation, one vendor can define a subsystem in a different way that other manufacturer, other vendor. So is there a definition of subsystem we are intending here to to benchmark maybe line cards or
Mhm.
processors or transceivers, or that
Yeah.
we can compare apples
Uh-huh.
with apples.
From my point of view, the subsystems, they're mainly the main criteria to judge a subsystem should be whether it's pluggable. So, such as the board or the transceivers, which they're pluggable, then they can be called a subsystem.
Okay, so maybe it would be good to add a kind of definition of subsystem. I'm not sure if it, because I didn't read the latest version, but maybe it would be good to add some terminology in this respect.
Yeah. That very good suggestion. Thank you.
Thank you.
We'll add it.
Thank you. Any other comment? Okay, thank you. Vladimir.
I have been following these drafts, and although we don't have focus on that, I think it would be nice to have some young modeled power meters in the picture, because then it reduces the hand waving in terms of defining how you actually measure things. If you can define something and monitor it with young push or any other methodology that already exists, then you can actually measure power consumption in a similar way that you configure the device. And we're doing that in different areas. There is nothing we have published as an open standard, but there is something to think about. If you can have a young model statistic of the power consumption, which can be measured in the same way, it would help this draft and make it much more applicable to reproducing the tests with different machines and power meters.
Do you mean young model for testing the energy efficiency?
Yeah, for example, like there is IV. IV is the only vendor independent model for test instruments, including power meters. And I guess you measure these things with something like how much they consume energy. So what we have done, we have translated IV model, which was something developed in the 70s, 80s, to young. And this can help to publish the data. Then you can see, okay, this power meter is of this type, of this. So it's one thing to think about.
It's right. It's right. Yeah, it's right. Thank you for.
Thank you.
Next one is Luis.
So hello everyone, Luis from Telefonica. I will present these updates of this draft about the calibration of measured time values between network elements. So a little bit of reminds about the motivation of the draft. So basically, the time stubs in the packets are using for different purposes. One, for instance, the control plane can leverage on them at the time of interpreting or analyzing or identifying topologies for low latency. So, for instance, with the flex algo algorithms, and also other different services can leverage on this for ensuring the different SLOs. No? This is the case of deterministic services, or even network slicing, or even the computation from the PCE. So the routers basically incorporate this capability of triggering measurements with either with T1 or T1 Lite or a stamp. But the point is that the different implementations has different levels of accuracy on the reporting of the time measure for the delay in a given link. So the idea is basically propose a benchmarking methodology so that we can identify the bias that the device introduced, the router basically introduced at the time of responding with the timestamp. The document has been already presented in IETF 121 and 122, and I will provide here some updates. So the measuring scenario that is being proposed is essentially to have a reference through a tester, so an initial reference. So basically bringing a fiber spool, measuring what could be in a certain scenario the latency introduced by this fiber spool, and then use this as a baseline once we start measuring the actual network element. So we are proposing to two, let's say, measurement types. One would be the single network element test. That it would be is the figure that you can see on the top, where essentially we create a loop in between two different cards of the network element, and we get the measurement, and then comparing with the baseline, we can identify if there is some bias on that measurement. And the second case, that would be the one on your right at the bottom, would be essentially to measure between two different network elements. So again, we can identify the bias that could be introduced by any of these network elements, and then with that bias, somehow calibrate later on the measurement once we process that in the control plane, for instance. So important here would be to report the measurement conditions. So what is the router, the model of the router, the hardware software description, and so as the length of the fiber spool as well. So somehow this would be the one helping us to create the baseline. So it's something that we need to take into account. Well, that we basically use always the same kind of fiber spool with the same characteristics and length and so. Then the description of the port, the line card, where the fiber spool is connected, the protocol used for the measurement, T1 light, the stamp, or whatever, and then the description of the test in terms of period, average, mean, max, calculations, and so on and so forth. And then a web tester that would be the one basically creating the ground truth measurement for correcting later on the bias. So going to the updates in this version number 03, we essentially incorporated or tried to address comments from the latest presentation. So we have had further clarification on the scope, so making clear what is the purpose. And also we have provided some clarification on the resolution needed. So basically here the point is that once we measure, we could play with different resolutions, but depending on the case for using this measurement, probably we can relax the resolution. An example is provided with the case of FlexAlgo. So if the FlexAlgo is collecting information from ISIS or OSPF, where the resolution is in terms of microseconds, so it's not worth it to go with a resolution farther than microsecond at the time of correcting the bias. So basically, we are proposing here, for example, rounding up the nearest integer value to microsecond. So next step for the document. So it's wonderful that we have this joint session between BMWG and IPPM. So it's an excellent opportunity to collect feedback from IPPM working group on this. Our idea is to complete the draft with the open points already identified. These are also documented in the document, and basically prepare a new version for next IETF, and hopefully, if everything is stable, ask for adoption at that time. So. Well, and also the idea of working on some lab experiments. There are situations, for instance, characterizing the accuracy of the measurement under load conditions, these kind of things, is something that we will try to get ready for Montreal, so that we can report if there is interesting to have this as well, to be taking this into account or not. And that's all from my side. Thank you.
Just a quick question, since we are out of time. Do you plan to make some hackathon test or something?
Could be an option. The difficulty here is to make available the devices, or probably providing remote access to the lab, and so could be an option. But the logistics are complex, but it's something that we can think on. Yeah.
Okay, just curious. Okay, yeah. Thank you.
Thank you.
Yeah, we have time for the last presenter. We only have 1 minute, but I don't know if you want to say something very quickly or just select one slide. That can be
one slide.
Yeah.
Thank you so much. So thank you for your patience. So only 1 minute, and I'm Kern from China Mobile. So today is the first time to propose this document in BMWG. So it's a benchmarking methodology for CATs. For those who are not next step, please. So next slide, please. So I'll just show the motivations. And so CATs is a traffic engineering approach, considering both compute and network metrics in order to select the appropriate server instances. So there is a working group in routing area called CAT. So the major objective here is to assess what kind of CAT matrix appropriate for instance selection, and then we will assess benefits and trade-off of multiple deployment solutions of CATs, and also we will analyze the effectiveness of CATs from different perspectives. Like you can consider the CPU utilizations, also because CAS can fit in different various use cases, and many of the use cases may consider service latencies and also like session continuity. So we have these as major objectives. Want to test the behavior of CAS. So yes, we will just skip all of this impacts, and this is basically the structure of the document will illustrate two test methodology for both centralized approach in which SDN controller will serve as the path collector for CAS, and then we will also test distributed approach, which the CAS ingress node will serve as a path selector. We will have multiple benchmarking tests, like we'll test the functionality of the CAS matrix collection and exposure, and also we'll test instance affinity and also the scheduling latency, and as well as the system utilization. And we will include more tests in the upcoming versions. So we will list the basic test setup for both of the solutions. And in the distributed solutions, the DUTs refers to CAS router, and all of the path selector function will place in the CAS router. So the control plane and forwarding plane function will be limited in the CAS router. In the centralized solutions, SDN controller will behave as the path selectors. So it is an illustration of distributed approach. So I'll just skip it. If you're interested, you can, yeah. So a quick summary. So it is the first time proposed this work in BMWG, and we want to seek for more common feedback if you're interested in the work. Thank you, and thank you for patience.
Thank you.
Yeah, thank you very much, and thank you everyone for attending.
Just one point. There are two missing presentations. So I invite the last two presenters to send a message to BMWG and IPPM to summarize your draft, to point out your slides, and to try to receive some feedback. So I'm sorry that you could not present.
Yes, please do that. And then to everyone who attended, it would be very useful to get some feedback, whether you think it was useful to have this combined session. We would like to hear that in order to plan for the next meeting. Thank you.
Thank you.
There's no so small areas. The topic is the same as exactly.
Do you plan to continue the experiment?
Yeah, let's discuss it.
Let's
Then
discuss.
get some feedback. Yeah. How we can be more interactive.
Okay.
Yeah.
Let's further discuss.